Good friends, welcome back. We're talking about Einstein, and we're moving on from the relatively simple material dealing with special relativity into the territory of the general theory of relativity, which still determines how we shoot rockets up into the distant skies and accurately hit relatively small objects out there. Indeed, we're sending some of our rockets out of our area entirely into distant space, thanks to Einstein and his general theory. Now, as we leave the special theory, which wasn't called the special theory until he came up with the general theory, Einstein wants us to realize that that train track idea can be replaced with a line with numbers on it so that we can literally measure distances that way. And moreover, we could draw a line directly at right angles from the line of the train track, and we could draw a line going up, and all of those would represent applicable areas of the special theory of relativity. Fascinating. Now, there are things I can say about that special theory that Einstein actually derived from other great physicists. We'll do that in a little while, but I want to introduce us to the general theory. The general theory was caused by Einstein's realization that nothing within our realm can exceed the speed of light, which is also the speed of time at the C realm. Now, nothing can exceed it, and indeed nothing can reach it, because at that point, light and time are moving at the same speed. Now, that realization tells Einstein that Newton, when he proposed that objects in the universe instantaneously attract each other, could not be correct. Instantaneous is faster than time. And so Einstein is forced to try to come up with another idea of how gravity works. It's not the result of instantaneous attraction between objects. And he thinks to himself, not the result of slower attraction between objects. There has to be some kind of connection between those objects for them to be attracted to each other. There can't be a leap over a distance. And indeed, Newton himself was troubled by that and said he couldn't figure it out, and he would leave it to other people to figure out. Well, Einstein was the other person who figured it out. And he figured it out using the idea of fields. The idea of fields traces back into the 19th century when Faraday realized that magnets do not simply attract each other directly, but in fact operate within a realm of fields that he illustrated by putting a paper on top of the magnets and sprinkling iron filings on top of the paper, and they rearrange themselves in such a manner as indicating what the fields were shaped like. Faraday was in astonishment. And now Einstein. In the 19-teens, he finishes General Relativity, 1915, a little more work in 1916, says, in fact, there's a field of space-time between objects or among objects. Better to say among them, because there are many of them. And they curve, this field curves around those objects. So you have a curvature around the Earth, a curvature around the moon, a curvature around the sun, curvatures around all the planets, and indeed the stars. And all that produces a field in which objects fall towards whatever it is that's closest to them. That is what produces the effect of gravity. We'll move on from this next time. Thanks so much for being with me today.